Hello, welcome to Codespiration. Let's solve another LeetCode question today, an easy one, which is LeetCode 20, valid parentheses. Okay, the question specifies that given a string S, we must determine if this string is valid or invalid. And the string contains just 3 or 6 characters, which are all parentheses, opening and closing. There is the rounded, the curly, and the square. Now, the criteria for validity specifies that opening brackets must be closed by the same type of open brackets, the same type of bracket, sorry, that's the corresponding closing bracket. Like in example 1, there is the rounded open bracket closed by the rounded closing bracket. Example 3 portrays this further or better, where there is a rounded opening bracket attempted to be closed by a square closing bracket, which makes this particular string invalid, as the output specifies false. Now, the second criterion specifies that open bracket must be closed in the order in which they are open, in correct order. That is to say, let's take example 2, for example. There is the rounded open bracket, open first. It has to be closed by a rounded open bracket. Subsequently, there is the square open bracket, which has to be closed by the closing square open bracket. Now, example 3 also portrays this. It shows the rounded open bracket being closed by the square open bracket, which makes it invalid. Example 4 gives a better explanation where there is the rounded bracket, then there is a nested square bracket. In this scenario, the square bracket had to be closed first. If this particular character had been a rounded closing parentheses, as in this one, this particular string would have been invalid because the brackets have to be closed in the order in which they are open. Since there is an open rounded bracket, now there is a nested square opening bracket. The square opening bracket has to be closed first. If there is, for example, another nested square opening bracket, or maybe a nested further nested curly opening bracket, that curly opening bracket had to be closed first before the square is closed and rounded. Now, the third criterion specifies that every closed bracket must have a corresponding opening bracket. I think example 3 captures this particular criteria because this particular square closing bracket does not have a corresponding opening square bracket. Therefore, the string is invalid. For example, let's say there are 2 closing square opening brackets. It will make the string invalid. Or let's say in this particular example 1, where we have a valid rounded bracket, if there is another rounded closing bracket, it will make the string invalid because it doesn't have an accompanying opening rounded bracket. Now, for this question, I think it is intuitive to think of the particular data structures we can use to accomplish the logic here. The first one we would intuitively think of would be a map. We need to find a way to map opening and closing brackets. Each closing bracket should be mapped to its opening bracket. That way we can now apply logic to see if that particular closing bracket is in the appropriate position, or if there are too many closing brackets of that type, and so on. The second data structure should be sort of a container to hold the opening brackets, since we need to skip over them to the closing brackets before we begin to apply our logic. The closing brackets basically are the more important part of this data. So let's jump into the code. Two data structures we've talked about is a stack, which will initialize as a basic Python list, and a map. Let's call it a hash map. Now this map, the basic Python map or dictionary, we would initialize with the closing brackets being the key, since they're the more important part of this data structure. We are organizing our map to query a closing bracket to produce its corresponding opening bracket for us to apply our logic to determine both position and type to check for string validity. So we have to initialize all the brackets we have been provided with in the question in our hash map. And we do the final one for the curly. And there we have our initialized hash map. Now the next thing we need to do is we need to, I think we have an intent problem. Next thing we need to do, we need to loop through our string character by character. We're not particularly interested in the indexes here, so we can access the character directly. The first thing we need to check for is if this particular character we are on at that point in time is in our hash map. If it's in our hash map, it simply tells us that that particular character is a closing parentheses, and remember, those are the more important parentheses. Those are the more important part of this particular data structure. So we check with an if. We say if character is in map, we now have to further check for if that particular character in map also happens to be the same value as the last character in the stack. Remember, if the string is valid, let's go to example 4. As we loop through the string, when we access this first character, we skip over it because that's a closing. We access the second one, we skip over it because that's closing parentheses. When we get to the third, it's closing parentheses. We need to check if the last character which we've skipped over, we're not really skipping over them, by the way. To make this logic very much more clear, we need to implement our else case. Now our else case specifies that if that character happens to be an open bracket, all we need to do is to append that character to the stack. So we append character to stack. Now we go back to our if case. Now, when we skip over the character, we now know that the last character in our stack has to be the corresponding opening bracket for the particular closing bracket we're on. So what we need to do is to check first if our stack has characters, so we don't run into an exception, and then we check for if the last character. To do that in Python, I think we just take negative index is equal to the value of the hash, or the value of the character we're currently on in our hash map. So we put that character as the index. Now, if that is true, what we need to do is to pop that character out of the stack. We need to pop that character out of the stack because we found a match. We're no longer concerned with that case. We're now moving on to the next. And we need the last character in our stack to be the corresponding opening parenthesis in our string. So we pop that character out of our stack, and then we move on to our else case. We just return false, because in that case we have else we return false because in that case we have a closing parentheses which does not have an appropriately placed opening parentheses, which is one of the conditions specified by the question. This is basically the bulk of our code. All that is left is that we break out of our for loop, and then we return true, but only on the condition that stack is empty. This is valid because if we have gone through all of our all the characters in our string and we have found valid matches, we should have popped out all the items on stack. So if stack is empty, we have a valid case. However, if stack is not empty, that means we have more open parentheses than there are closing parentheses. That also should give us a false string. So this is the bulk of our code. We initialize our two data structures to handle the logic of our code. We loop through our list, check if the items are in our hash map, if the characters are in our hash map. When we get a character in our hash map, we have hit a closing parentheses. We check if there is an accompanying opening parentheses as the last character in our stack. If this is correct, we have a valid match. So we pop out that last character in our stack. We consider that case dealt with. Now, if that is not the case, we return for false. While looping through our list, if we hit a case where the character is not in hash map, then we are at an opening parentheses. So we simply append that character to our stack. Let's see if this runs. Ooh, we have a bug. Oh, if character in hash map. Let's see if this runs. Aha. So this runs. We're passing out test cases. Let us see if we pass the overall. And we did. So I hope this helps, and I hope this explanation was easy to understand. Stay tuned for more content like this.